Hello everyone. Let us see the first chapter of this Engineering Mathematics 2, the complex numbers. Let us see first definition. The complex number can be represented in the form of x plus iy, where x and y, these two numbers, are real numbers, and I, this number, is a imaginary number whose value is I square is equal to minus 1, or I is equal to under root of minus 1, and it is generally denoted by z is equal to x plus I y, where x is a real part, x is called real part, and y is called imaginary part of this complex number z. Complex conjugate. Definition of complex conjugate is: if z is equal to x plus iy is one complex number, then its complex conjugate is defined as, it is denoted as z bar, and it is defined as x minus iy, just opposite of this middle sign. If it is plus, take minus; if it is minus, take plus. This is called complex conjugate of each other. Okay. Now, equality of two complex numbers. Suppose z1 is one complex number, x1 plus iy1, and z2 is other complex number, x2 plus iy2. These are two complex numbers. Then if z1 is equal to z2, means these two complex numbers are equal, then we have x1 is equal to x2 and y1 is equal to, must be equal to y2. Then and then only these two complex numbers are said to be equal. That means their corresponding real and imaginary part must be equal with sign. Now let us see the modulus of z. Next definition: if z is equal to x plus iy is any complex number, then modulus of z or mod of z is denoted by these two bar. Between these two bar, it is z, that is mod of z, and it is defined as mod z square is equal to x square plus y square, or mod z is equal to under root of this x real number square plus imaginary number square. For example, suppose z is equal to 1 plus 2i, then mod z square is 1 square plus this 2 square, which is equal to 5, or mod z is root of root of 5. Second number, if it is minus 2 plus I, then mod z is this minus 2 square plus this y, which is attached to I. If any number is not there, then take 1 into I. That's why 1 square here, imaginary part. Minus 2 square plus 1 square is 4 plus 1, that is under root of 5 is the mod value of this complex number. This is called modulus of z. Now let us consider geometrical representation of any complex number z. This is a Aragon diagram or geometrical representation. This is also called Aragon diagram. Of complex number. Okay. This is x and this is y, xy plane, single plane. Then this is suppose origin. This is any p point in two plane xy, where this distance is, this is perpendicular, this is parallel to y axis, that's why it is distance y of this point, and this is distance x. Suppose this is r, this is hypotenuse, and this is theta angle between these two x and r. Okay. Then complex number z, x plus iy, can be represented as the point, this is a point pxy in xy plane. This is called the Aragon diagram or geometrical representation of any complex number. Okay. Now let us see the polar form. As if now we have seen xz is equal to x plus iy, x and y are real numbers, that's why it is called Cartesian form. Now consider the polar form of a complex number. Let z is equal to x plus iy be the Cartesian form of a complex number z. Then x is from this diagram. What is x? Is hypotenuse into cos of theta. Okay. Or from this diagram we know cos theta is equal to adjacent side upon hypotenuse, x upon r, and sin theta is equal to opposite of this angle, distance is opposite side upon hypotenuse. From that we know x is equal to r cos theta, and y is equal to r sin theta. Okay, and r square, we know r square is equal to, it is by Pythagoras theorem, x square plus y square. And tan theta, taking tan of this theta means sine upon cos, we get y upon x. R gets cancelled. Okay, now put the values this x and y in this Cartesian form. We get x is equal, z is equal to r cos theta plus I r sin theta. Take r common, we get r cos theta plus I sin theta. Everywhere x and y replaced by r and theta, which is called the polar form of a complex number z. Okay. Now let us see how to calculate theta, where theta is called the argument or amplitude of a complex number z. In different quadrants we have to find. Okay. While calculating the complex numbers arithmetic, we have to find the r and theta, and r is very easy. In any quadrant, r is nothing but the square root of x square plus y square. Whether x and y are positive or negative, it doesn't matter. But while calculating theta, it depends on the sign of x and y. Okay, let us see, in 4 quadrants we have to find theta. Definition of theta is different. Now let us start with first quadrant. Let z is equal to x plus iy with the complex number, where x and y are greater than 0 means both x and y are positive. That means it lies in first quadrant. In first quadrant, we have x and y positive. That's why for this particular point, the theta is defined as tan inverse y upon x, as it is as our definition of theta. Okay, this is same for the first quadrant. Then z becomes r cos theta plus I sin theta. This definition is same for everywhere in any quadrant, but theta is different for calculating purpose. In every quadrant theta is different, where theta is called argument or amplitude of z. Both start from a, argument or amplitude of complex number z. Suppose in let us see from for second quadrant, z is equal to x plus iy, where x is suppose less than 0 and y is greater than 0. In second quadrant, obviously x is less than 0, x is negative, and y is positive. In second quadrant, diagram is same. Okay, suppose this is alpha, and now this becomes theta. Okay, that's why theta in this case is pi minus tan inverse y upon x. The definition for calculating theta for this quadrant is pi minus tan inverse y upon x. This total distance is, the total angle is pi 180 degree minus this alpha. What is alpha? Is our theta in first quadrant. What is theta? Tan inverse y upon x, as it is. Okay, that's why it is pi minus tan inverse y upon x. Taking x and y positive form. Whatever x and y are, if they are negative, taking x and y positive for this definition. Okay, irrespective of sign, we have to take that. Now for let us see for third quadrant, z is equal to x plus iy, where x and y both are negative. Obviously point lies in third quadrant in negative axis. Okay, the diagram is same, just theta, this is theta and this angle is alpha. That's why this total angle is pi plus this alpha. It becomes our original theta. Theta becomes pi for this third quadrant. Theta can be calculated as pi plus tan inverse alpha y upon alpha. Okay, this is pi minus, this is pi plus, this is tan inverse y upon x, this is pi minus tan inverse y upon x, this is pi plus tan inverse y upon x. Now let us see for fourth quadrant. Suppose this is fourth quadrant, x plus iy can be in the fourth quadrant, x is greater than 0 and y is less than 0. Y is negative, x is positive. And then this is the same diagram. Therefore, suppose this is alpha this is theta and this angle is alpha. Then theta becomes, for this um, quadrant, theta can be calculated as 2 pi minus tan inverse y upon x. Okay, it's called the angle or argument or amplitude of z in four quadrants, taking x and y in positive form for the rest of the three remaining all the forms. Okay, you have to just mug up these formulas. Now let us move. Exponential form of the third form of complex number is exponential form of a complex number z. Let z is equal to x plus iy as usual, and we know this is cos theta plus I sin theta is e raised to I theta. This is the definition of exponential. E raised to I theta is cos theta plus I sin theta, or cos theta minus I sin theta becomes e raised to minus I sin theta. Then z becomes x plus iy, that is, this is a polar form of z complex number r cos theta plus I sin theta, and cos theta plus I sin theta replace this by e raised to I theta. That's why this particular form, in some example we are going to use exponential, this form, okay, is called the exponential form of a complex number z, where r is as usual tan inverse y upon x according to four quadrants. The theta is different, and theta is the amplitude or argument. Okay, now let us see the properties of complex number. That let z is equal to x plus iy. Then first is real part of z. It's denoted in short form as re of z. Real part of z is nothing but z plus z bar. Z bar is a complex conjugate. Is it taking the middle sign as a opposite of that sign? It is called complex conjugate. Addition of z with complex conjugate divided by 2, it comes as real part of z, which is x. Okay, value of x. Imaginary part of z, that is y, that is I m of z, is equal to z minus z bar upon 2i. Okay, now z1 plus z2 bar. Bar is a complex conjugate of this addition, is nothing but z1 bar plus z2 bar. z1 into z2 bar is z1 bar into z2 bar. z1 upon z2 bar is z1 bar upon z2 bar. These are the properties. Z into z bar is equal to mod of z square, which is equal to mod of z bar square. It is multiplication of complex number with his complex conjugate. Mod of z1 into z2 is nothing but mod of z1 into mod of z2. Argument, that is theta. Argument of angle theta is argument of z1 into z2 is equal to argument of arg of, this is short form of argument, that is theta, z1 into z1 into z2, which is equal to argument of z1 plus argument of z2. Okay, argument of z1 upon z2 is argument of arg of z1 upon z2, which is nothing but opposite of this definition, that is argument of z1 minus argument of z2. Okay, these are some properties of complex numbers. Let us start with the example. Our example number 1. Find modulus and argument. That means we have to find mod of z, that is r value, and argument, that is theta value of this complex number z is equal to minus half plus root 3 by 2 I. Why it is called complex number? Because it consists of I. Any number which consisting of I is nothing but a complex number. Okay, any real number is a complex number. Okay, let z is equal to, for example, one plus I is a complex number. Only I is also a complex number. 0 plus, you can write this as 0 plus I. Okay, what is our definition? Z is equal to x plus iy. This type of any number is a complex number, right? Where x and y are real number. What are real numbers mean? This is the real line. 0 is there. 0 is a real number. 1, 2, 3, 4. These are positive integers. These are real numbers. -1, -2, -3. These are also negative integers. These are real numbers. Addition of all including 0 becomes whole numbers, and in between 0 and 1 half is there, 3y. In between this 3/2 is there, right? 2/3 is there. These are fractions are also real number. All these things are real number. X and y can be anything. That's why it is also a real number. Only I is also a real number. It can be represented as this form. Only 1 is also a real number, complex number. 1 is also complex number because it can be written as 1 plus 0i, right? Half is also imaginary complex number because it can be written as a half plus 0i, right? Okay, fine. Where to find out modulus and argument of this complex number? Let z is equal to this as it is. Here x value is this real part of this is minus half, and y is imaginary part of this, that is root 3/2. It lies in obviously second quadrant, right? X is negative, y is positive, that means it lies in second quadrant, because this information we need for calculating argument value of this. Let us see first modulus. Modulus is nothing but r value mod of z. This is called mod of z, which is equal to r, which is equal to under root of x square plus y square. Under root of x value is minus half square plus y value is root 3/2 square. Half minus half square is plus 1/4 plus root 3 square is 3/2 square is 4. 3 plus 1 4/4. Root of 1 is 1. Modulus of this complex number is 1. Now we have to find out argument, that is theta value. Theta is nothing but for second quadrant pi minus tan inverse y upon x. Pi minus tan inverse, put the values, y is root 3/2 upon x is 1/2. This 2 gets cancelled because it is lies in both denominator, in both numerator and denominator. That's why 2 gets cancelled. Answer is only root 3. Okay. Now what you have to do? Just you have to find out tan inverse root 3. Take a calci. Okay. Put this in a degree form. Math and degree is the only two in the status bar here. Okay. Don't put it in any other form, in any other status. Okay. We have to find out tan inverse root 3. This is a tan inverse. Shift tan inverse. Okay. Root 3 here. This is root 3. Complete the bracket. Okay. Equal to, this is 60. But in every answer, in throughout the M2 or M1 or M3, we are consider only a radian form. Now how to convert this 60 degree into radian? The 60 into pi upon 180 becomes the radian. That becomes 60 into 3 is 180, pi upon 3. That's why I take pi by 3 here, not 60. Okay. That's why pi minus pi by 3 is 2 pi by 3. Answer for our theta is 2 pi by 3, which is argument or amplitude, and r is a modulus of this complex number. Okay. R is very easy because it doesn't matter where x is positive or negative, square of this becomes positive. But theta, it depends on the quadrants, positive and negative sign, and we have just seen how to calculate with these diagrams or in these quadrants. These are some homeworks for you. Question is same, find the modulus and argument of these complex numbers. Okay, these are the 4 examples for homework. Same question. Now let us see next example. If argument of z plus 1 is equal to pi by 6 and argument of z minus 1 is equal to 2 pi by 3, we have to find out z. This is given thing. We have to find out z. Z is our complex number. Let us start with z. Let z is equal to x plus iy. This we have to find out. Means we have to find out x and y. Okay. Start with this first equation. First given thing. Argument of z plus 1 is equal to pi by 6. Put the value of z here. X plus iy. Argument of x plus iy plus 1 is equal to pi by 6. Now what is argument of any complex number? What is here? See, this is our theta. Take tan on that side, we get tan inverse y upon x is our general uh, definition of argument or amplitude. What is this theta? Tan inverse imaginary part upon real part. We are going to use this definition here. What is imagined argument of this means? We have to find out imaginary part upon real part. What is imaginary part means? The value or part that which is attached to I. Which part is attached to I? Only y. That's why it is called imaginary part. That's why imaginary part y upon real part, this is x and plus 1 is a real part because it doesn't contain I. That's why it is a real part. That's why definition of argument of this number becomes tan inverse imaginary part divided by a real part. Okay, is equal to pi by 6. Now we have to solve this. Take tan on that side, we get y upon x plus 1 is equal to tan pi by 6, and we have to find out tan of pi by 6. Now again, how to calculate tan pi by 6? Take a calci tan, this is a tan, normal tan, and pi by 6. Again we cannot write pi upon 6 because this pi is a different. Okay, this is a pi is a number, here pi is a angle is pi means 180 degree. 180 divided by 6 is a 30 degree. That's why tan of 30 or 180 divided by, you can write in this form also, complete bracket complete. Answer is root 3. Sorry, it is not 3, it is 6. Okay, answer is root 3 by 3. Okay, now cancel 1 root 3 from this. Answer is 1 upon root 3. Okay, answer is root 3 by 3. And what is root 3 by 3? In 3 1 root is there, that's why answer is 1 upon root 3. Okay, on calculator you can calculate anything, just be careful about brackets and all those things. Okay, 1 upon root 3 is there. Now we have to make one equation from these two, LHS and LHS. Take x plus 1 on that side, root 3 on that side, we get x plus 1 is equal to root 3y. Take x and y on one side, constant on other side, we get, take this on this side, x minus root 3y becomes minus 1. Call that equation number 1. This one equation we get it from first given thing. Now similar way, let us solve the second given thing. Argument of z minus 1 is equal to 2 pi by 3, it is given. The argument of put x z value is x plus iy minus 1 is equal to 2 pi by 3. Tan inverse, we know argument similar way, but to find out imaginary part is y, real part is x minus 1. Therefore tan argument of this number is tan inverse of imaginary part divided by real part, y upon x minus 1 is equal to 2 pi by 3. Now take tan on that side, we get y upon x minus 1 is equal to tan 2 pi by 3. Y upon x minus 1, x minus 1, calculating same way, tan 2 pi by 3. This is tan 2 pi by 3. 2 into 180 divided by 3. Bracket complete. Answer is minus root 3. Okay. Now make a equation, one more equation. Take x minus 1 on that side, we get x minus 1 into minus root 3 is equal to y. Take minus root 3, multiply these brackets, we get minus x root 3 minus minus plus root 3 into equal to y. Take y on that side or this term on that side, we get x root 3 plus y becomes root 3. Okay, call this equation number 2. Now these are the two equations in x and y. We can easily solve these two equations like this. Okay, this is simple arithmetic. From this we get x is equal to 2 by 4, that is 1 by 2, and y is equal to root 3 by 2. Therefore z, what is our question? Finding out z. Therefore z is equal to x plus iy. Put x value half plus y value root 3 by 2. This is our answer. Let us move to next example. Find real part and imaginary part of this complex number. This is one complex number because it contains I. And we have to find out real part, that means the real part of z, and imaginary part which is attached to I. Real part means which is not attached to I. Imaginary part is which is attached to I. Before that, we have to convert this numerator denominator form into a simple form. Simple form means I is there in numerator, which is doesn't matter. If it is numerator contains I, it doesn't matter. But when it comes to denominator, it create a problem because we cannot we cannot divide this numerator. We cannot divide denominator. Like for example, suppose 1 plus 2 divided by 4. We can write it as 1 by 4 plus 2 by 4, right? Because in numerator addition doesn't matter, we can easily divide. But in denominator, if it is reverse, right, we cannot write it as 4 by 1 plus 4 by 2, right? Denominator never divides numerator, but denominator divides numerator. It is not in this way. That's why if I is there in the denominator, it creates problem. That's why our first job is we have to cancel this I from the denominator. We have to multiply and divide this number by the complex conjugate of the denominator. What is complex conjugate of this number? Just replacing the middle sign by opposite sign. Here minus, that becomes 1 plus I is the complex number of the denominator. We have to multiply the numerator and denominator by 1 plus I. This is the simple process. Now let us start. Z is equal to 2 plus 3i upon 1 minus I. Multiply and divide by complex number of complex conjugate of this number. It becomes 1 plus I into this, 1 plus I into this number. Now multiply throughout these brackets as simplification by multiplication of these two brackets. How we do in a regular fashion, we have to do in that way only. 1 into 2 plus 3i as it is, I into 2 is the 2i plus 3i square, divided by this a plus b into a minus b, that is a square minus b square. And we know I square value is minus 1, that's why it becomes 2 plus 3i plus 2a becomes plus 5i, and it becomes minus 3, and 1 minus of minus 1, it becomes 1 minus 3 is minus 1 plus 5i divided by 1 plus 1 2. Now we can easily divide this numerator by